Okay, good evening. So Rohini rockets are sounding rockets. So what are these? For what purpose we are using these Rohini rockets are sounding rockets? So one is for technological demonstration purpose. One is for technological demonstration purpose. Next one is other than this technological demonstration. Wait, technology demonstration purpose. Next one is a testing purpose, testing of any technologies, upper atmospheric studies, and next one is meteorological studies. So these are the areas where we are focusing regarding these Rohini rockets. Remember that with Rohini rockets we cannot launch satellites into the orbits. We especially develop these Rohini rockets for that purpose only. Next one is what are the three versions of Rohini rockets that are currently in operational? Means RH200, RH300 Mk2, RH560 Mk2. 200, 300 means it's the diameter of the rocket. Okay, yes. What is that? We have to start. Copy this table. Copy this table. Okay, okay. Then we will do one thing. First, we will do this. There are some people who didn't cover this thing. So after this, I will take SSL. Okay, just you have to wait. Okay, so first you copy this. Copy this operational sounding rockets. What are the three operational sounding rockets are there? Currently, these are the three rockets where it is operational, friends. RH200, RH300 Mk2, RH560. So from which launch station we are able to launch this? What are the launch stations that we are using? Tumba Equatorial Rocket Launching Station. And Tumba Equatorial Rocket Launching Station is also known as Vikram Sarabhai Rocket Launching Station. And one more thing is, we can launch these rockets from Satish Dhawan Space Center also. We can launch these rockets. Okay, no? RH200, RH300, and RH560. RH200 payload is 10 kgs, and it can be used at altitude of 80 kilometers. And its purpose is meteorology and launched from Tumba Equatorial Rocket Launching Station. So why Tumba was selected as an initially why it was a small fishing village was selected for starting the outer space services from India means magnetic lines in India passes through Tumba village. Magnetic line of Earth will be there. That magnetic line of Earth in India will pass through a small village known as Tumba. That is a small fishing village in Kerala. So hence that particular site was selected as an ISRO starting site of ISRO for launching of rockets. Everything. Completed. Right click this. Rohini rockets. One more minute. Okay. Okay. So Rohini rockets are used for the following purposes. One is technology demonstration purpose. Next one is testing of new technologies. Next one is aeronomy studies. And next one is for meteorological studies. Next one is for meteorological studies. Okay, no? So this is what the use of this Rohini are sounding rockets. Aeronomy means upper atmospheric studies. Got it? So that is what regarding to the Rohini are sounding rockets. The next version of rocket system is SSLV, small satellite launch vehicles. Those who completed, listen once again. Those who are not completed, you can make a note of it. Is it clear? So what is this small satellite launch vehicle? How many stages will be there in this small satellite launch vehicle? So 3 stages will be there in this small satellite launch vehicle, friends. SSLV, small satellite launch vehicles. There will be 3 stages. And this is the place where rockets are placed. Means that is what means this is a payload of SSLV. So is stage 1, stage 2. This is stage 3. So in all these 3 stages, what is the fuel that is used? Solid fuel. Here solid fuel is used. Here also solid fuel is used. In all these 3 stages. And this stage we call it as an velocity trimming module. That we call it as an velocity trimming module. So in all these 3 stages, solid fuel is used. And next one is velocity trimming module is there. Velocity trimming module means with this velocity trimming module, while launching the satellites into the orbit, we can enhance the velocity of the rocket, or we can reduce the velocity of the rocket. We can manipulate the rocket velocity with the help of this technology. So why? Because why we have developed like this? What is the necessity of this? Means with this what we call it as a small satellite launch vehicles, we will launch nano satellite, small satellites, and so mini and small satellites into the orbits. So nano satellites will have different weight, mini satellites will have different weight, and next one is small satellites will have a different weight due to their different payloads. So they have to maintain the approximate speed while launching the satellites into the orbit. Okay, now, if approximate speed is not maintained, what happens means orbit of the satellites cannot be maintained. So for every satellite from the ground, we will design the orbit of each and every satellite, and it has to be launched into that particular orbit only. And for launching of satellite into a particular orbit, we need to maintain sufficient speed. Okay, now, so like that we will design what means so velocity of a particular satellites. So what is the satellites? What type of satellites that will be launched into the orbit by this SSLV means? I told that small satellites, nano satellites, as well as mini satellites will be launched. What is this nano satellites, micro satellites, and small satellites? I will give you information regarding that. So this it has a payload carrying capacity of how much means below 500 kgs. Into which orbit it can launch these satellites with the help of small satellite launch vehicles means lower Earth orbits. Lower Earth orbits at a, so this in the lower Earth orbit that is only 5 kilometers of range orbits. Sorry, 500 kilometers of range orbits. Lower Earth orbits means 500 kilometers of range orbit only. We will launch satellites with the help of small satellite launch vehicles, not more than that. Okay, now that to 300 kg satellites, 500 kg satellites we will launch into the orbit with the help of small satellite launch vehicles. So why India is focusing on developing of these small satellite launch vehicles? What is the necessity of these small satellite launch vehicles? So earlier, before development of these small satellite launch vehicles, we used to launch these nano satellites, micro satellites, small satellites with the help of what means PSLV and GSLV rockets. It becomes too costly, and that too. So when we are launching multiple of satellites or hundreds of satellites in a single launch, so managing means we need to perfectly launch these multiple of satellites into the orbit. Okay, now that becomes the difficult task there. Okay, now to avoid this, and that too, launching cost becomes very high. To overcome this, we started developing small satellite launch vehicles. That is one benefit. Along with this benefit, we have added benefits that are there. What are those added benefits? Means one is launch on demand services. What is launch on demand means whenever we want, we can launch the small satellite launch vehicles. Okay, now, so that is what launch on demand services. See, if suddenly US came to India and requested ISRO to launch 94 satellites. So there are 94 satellites from USA. It has to be launched. So we won't say no to the USA. Yes, we are ready to launch because we have a separate vehicle for that. That is small satellite launch vehicles. Okay, now, like that, launch on demand services can be provided to any country. So is ISRO is benefited or not? Yes, once upon a time it is a non-profit organization. With such kind of vehicles and launch vehicles, ISRO can become a profit organization. Okay, and we can use that profit for research and development purpose, further developments. Got it? That is what. And next one is low per kg launch cost. Launch cost becomes cheaper. Next one is reduce the turnaround time. What is this reduce the turnaround time means? What means? So this once already we have launched one rocket. Okay, now to launch another rocket in case of PSLV GSLV, it takes at least 1 week. Okay, now, so 3 days to 1 week is required because once PSLV GSLV was launched, total the basic infrastructure facility, that is launch facility, basic infrastructure facility of launch pad will be destroyed. Okay, hence we need to reconstruct it and we have to launch it. Okay, but in case of SSLV, we can go for second launch within 24 hours. That is what reduce the turnaround time means. Okay, the next one is increase the production rate from industries. We can fastly produce these small satellite launch vehicles. We can launch the rockets whenever we want. Okay, the next one is multiple satellite mounting option for nano, micro, and small satellites. We can, in a single launch, we can go for multiple of launches. Okay, the next one is so this capability of launching 6 to 8 missions per year. We can launch 6 to 8 missions per year. Means number of launchings will also be increased. What is the special rocket launch station that was designed for launching small satellite launch vehicles? Means Thuthukudi rocket launching station in Tamil Nadu. That is a new rocket launch station that was developed especially for small satellite launch vehicles. Friends. That is what all about this small satellite launch vehicles. And which organization is involved in manufacturing of this small satellite launch vehicles? Means New Space India Limited. New Space India Limited is a commercial wing of ISRO. This commercial wing of ISRO is involved in manufacturing of this small satellite launch vehicles. Friends. So this is what the organization New Space India Limited is involved in manufacturing of this satellites. Rockets. Okay, so make a note of this. SSLV, small satellite launch vehicles. New Space India Limited. New Space India Limited is involved in manufacturing of this. Is involved in manufacturing of this rocket system. Is involved in manufacturing of this rocket system. It has a capability of launching. It has a capability of launching nano satellites, micro satellites, and small satellites. And small satellites. Okay, the next one is it has 3 stages. It has 3 stages and all are of solid propellant. It has 3 stages, all are of solid propellants. All are of solid propellants. Okay, next one is velocity trimming module. Velocity trimming module. Introduced in SSLV. Velocity trimming module that was introduced in SSLV is useful for launching the satellites. Velocity trimming module that was introduced in SSLV useful for launching the satellites into the orbits, launching the satellites into the orbits at different velocities. At different velocities. At different velocities. Okay, next one is completed writing these ones. Benefits. Benefits of small satellite launch vehicles. What are the benefits of small satellite launch vehicles? What benefit we have? Benefits of small satellite launch vehicles. First benefit is okay, now, low cost per launch. Low cost per launch. And next one is another one is Launch on demand services. Launch on demand services. Launch on demand services can be provided. Third one is reduce the turnaround time. Reduce the turnaround time. Reduce the turnaround time. Okay, next one is increase the production rate from industries. Increase the production rate from industries. Increase the production rate from industries. Okay, now increase the production rate from industries. Next one is multiple satellite mounting option. Multiple satellite mounting option. Multiple satellite mounting option. Okay, no? So these are the benefits of what we call it as small satellite launch vehicles, friends. Okay, no? So this is what regarding to the small satellites and Rohini rocket systems. Got it? So up to this, I think it is common for everybody. Okay, no? Next from here, everybody has to write. Take heading. Do you know? Okay, no? Take heading. Do you know? Satellites based on their weight. Satellites based on their weight categorized into following types. Categorized into the following types. Means pico satellites means pico satellite 0 to 1 kg. 0 to 1 kg. Nano satellite. Nano satellites 1 to 10 kgs. 1 to 10 kgs. Micro satellites. Micro satellites 10 to 100 kgs. 10 to 100 kgs. You know, mini satellites. Mini satellites 100 to 200 kgs. 100 to 200 kgs. Actually, small satellites 200 to 500 kgs. You know, large 500 to 500 above, right, like this, 500 above, 500 and above. Okay, no? That is what the categorization. And while you are going through this newspapers like that, you may hear about CubeSat satellites. CubeSat. What is this CubeSat means? It comes under the category of nano satellites. Okay, now if a satellite was manufactured in a perfect square shape, then we call it as a CubeSat. Make a note of this also. CubeSat satellites are a class of nano satellites. Class of nano satellites which are of in a square shape. Which are of in a square shape. Square shape. Okay, next one is another point. So this is what regarding to the types of satellites. Got clarity on this? Okay, next one is while launching the satellites into the orbit. While launching the satellites into the orbit. Satellites into the orbit. In heavier satellites. In heavier satellites, it has to maintain a speed of. It has to maintain a speed of 11.2 kilometers per second. Maintain a speed of 11.2 kilometers per second. But in case of nano satellites and small satellites. But in case of nano and small satellites, it depends upon the payload of the satellite. It depends upon the payload of the satellite. It depends upon the payload of the satellite. Okay, no? Next one is payload of rocket means the weight, right in the bracket, satellites. The weight that a rocket is able to carry. That a rocket is able to carry. Okay, that is what regarding this. Next one is payload of satellite means. Receivers, transponders that are present in the transponders that are present in it. Transponders that are present in it. You know, that is what the payload difference of satellites, payload difference of rocket. Okay, now see when you see this, so this when we are going to the types of rocket systems, especially operational rockets, as the version of the rocket changes, what happens means, so payload carrying capacity increases. Okay, now if you see PSLV has payload carrying capacity of 1700 kg approximately. If you go to the GSLV Mk2 or LVM2, we call it as, it has 2000 kg of payload. If you go to this GSLV Mk3 or LVM3, 4000 kg of payload. Okay, now as the version of the rocket increases, payload carrying capacity increases. So that is a benefit for India. Got it, students? And different purpose, we are using different types of rocket systems. Got clarity, students? This is what all about the operational rockets of India. So in this contest, we will write one question regarding to this, students. Everybody should write answer here itself. Okay, now make a note of this. Discuss the difference between PSLV and GSLV. Discuss the difference between PSLV as well as GSLV. PSLV as well as GSLV. So what is the first difference is? What is the first difference regarding to this? No, you have to write one by one in a proper order. First, PSLV means Polar Satellite Launch Vehicle. GSLV means Geosynchronous Satellite Launch Vehicle. Start writing with that. Start writing with that. PSLV means Polar Satellite Launch Vehicle. Polar Satellite Launch Vehicle. GSLV means Geosynchronous Satellite Launch Vehicle. Geosynchronous Satellite Launch Vehicle. Next one is how many stages in PSLV? 4 stages. How many stages in GSLV? 3 stages. Write that. 4 stages in PSLV, 3 stages in GSLV. Okay, the next one is Vikas engine is used in PSLV. Vikas engine is used in second stage. Vikas engine is used in second stage. In GSLV MK2. In GSLV MK2, second stage as well as 4 strap-on motors. In GSLV MK2, second stage as well as 4 strap-on motors. 4 strap-on motors. But in GSLV MK3, liquid stage, 2 Vikas engines. Liquid stage, that is second stage, 2 Vikas engines. Liquid stage, that is second stage, 2 Vikas engines. Is it clear, students? Okay, na? Like that you have to write. Next one is another one is, what is another one? Payload carrying capacity. Now tell me the payload carrying capacity. Payload carrying capacity of PSLV is 1700 kgs approximately. Payload carrying capacity is 1700 kgs. GSLV MK2 is 2000 kg. GSLV MK3 is 4000 kg. GSLV MK2 2000 kg. GSLV MK3 4000 kg. So you have to represent like this. Every point you have to make a note of it. Okay, students. That is what payload carrying capacity. No cryogenic engine in PSLV. Cryogenic engine is used in GSLV. No cryogenic engine in PSLV. But cryogenic engine in GSLV. Okay, now PSLV is initially designed for remote sensing satellites. PSLV was initially designed for remote sensing satellites, whereas GSLV for communication satellites. PSLV initially designed for remote sensing satellites, satellite launch, whereas GSLV was initially designed for launching communication satellites. Launching communication satellites. Okay, now any difference? So in PSLV, solid and liquid fuels are used in alternative manner, but in GSLV, solid, liquid, gaseous fuels are used in a sequential order. In PSLV, solid and liquid fuels are used in an alternative manner. Yes, yes, you are alert. Solid and liquid fuels are used in an alternative manner. So while you are writing answer to the questions, you should write in a proper sequential manner. You should not vomit whatever you know. Okay, na? Are you getting it? Don't give puzzle to the what you call it as invigilators or evaluators. Okay, na? They don't know anything. Like that, you have to think and you have to write everything like that. From the basic, you have to start writing. If you are not writing what is PSLV and what is GSLV, if you write whole story of PSLV and GSLV also, basic point was missing, na? Okay, na? Because evaluator doesn't know what he is correcting. First, you should make aware of that. Got clarity, students? Now, is it clear? Okay, that's what. And that is what the difference between PSLV as well as GSLV. Next one, we'll go for futuristic launch vehicles. Take heading, futuristic launch vehicles. What are these futuristic launch vehicles? Reusable launch vehicles. Take heading under this. You have to take heading reusable launch vehicles. Futuristic launch vehicles. Under that, you should use reusable launch vehicles. Reusable launch vehicles. So what is this reusable launch vehicles? For what purpose we are using these reusable launch vehicles? So what is the benefit of using these reusable launch vehicles? So far, any country has developed these reusable launch vehicles. So if it is, what is that? SpaceX. That is a private company. Okay, now Elon Musk company. That is a SpaceX. Under the SpaceX, they have manufactured Falcon rockets. These Falcon rockets are reusable rockets. Okay, now so these Falcon rockets, which are reusable rockets under the SpaceX, they are used for launching of satellite. Sorry, they are used for multi-purpose. What is the benefit of developing these reusable launch vehicles? First one is what means regarding to these reusable launch vehicles is reducing the space debris. Okay, now satellite launch cost can be drastically reduced. Satellite launch cost can be drastically reduced. Next one is another thing regarding to this is what means regarding to these reusable launch vehicles. So space economy means launch on demand services when we are providing means India is able to provide satellite launch services to many countries in the world. Okay, now when satellite launch services are provided, space economics, okay, now means satellite launching cost in a space economics will increase or not? That is the thing. That is one thing, students. And another important point regarding to this is what means regarding to this reusable launch vehicles. So in future they are promoting space tourism. Now also space tourism is there in US countries, not India countries. Ticket is very cheap. That is only 300 crores. With a 10% discount, they are giving it 290 crores of ticket cost. They will show you total solar system planets, and again they will bring you back from Earth. Also we can see that now. Okay. So that is what space tourism. For promoting of space tourism, these reusable launch vehicles are required, especially for India like countries to send astronauts into the space. Okay. Now, in 1960s itself, US and what we call it as Russia sent humans into the space. But still in 2023 also, what we call it as India is unable to send astronauts into the space. Okay. Now, and we are trying to send astronauts into the space. When we develop reusable launch vehicles, that will become a base platform for this or not? Yes. In future, we want to develop human-rated launch vehicles. For that, we started developing a technology of reusable launch vehicles. Are you getting my point, friends? That is what we are doing regarding this. Got it, friends? Shall we write regarding these benefits? Okay, so write like this. Currently India is in developing stage. We don't have these reusable launch vehicles. And in future, we want to develop these reusable launch vehicles, friends. Okay, make a note of this. Reusable launch vehicles are the type of unified rocket systems. Unified rocket systems. It has following benefits. It has the following benefits. First one is satellite launch cost can be reduced. Satellite launch cost can be reduced. Satellite launch cost can be reduced. Next one is launch on demand services can be provided. Launch on demand services can be provided. Launch on demand services can be provided. Next one is India's role. India's role in world space economics. In world space economics. In world space economics can be enhanced. Okay, that is one thing. Next one is other than this, space tourism. Space tourism activities can be promoted in future. Space tourism can be promoted in future. Okay, next one is. Okay, next one is space debris can be reduced. Space debris can be reduced. Space debris can be reduced. And next one is yes, space debris can be reduced. Another thing is it becomes this stepping stone for. It becomes a stepping stone for sending astronauts into the humans. In sending astronauts into the humans. In sending astronauts into the humans. Space. In sending astronauts into space. Okay, na? That is what regarding to these reusable launch vehicles. Currently, what is the reusable launch vehicle that is there in the world? Falcon rockets. Belongs to SpaceX. Those are the private company. Okay, na? That doesn't belong to NASA. Got it? That is what. And India is in currently developing stage regarding the reusable launch vehicle. What is the reusable launch vehicle and what are the benefits of reusable launch vehicle means that. So this is the previous question regarding to the rocket system students. Go through this previous question. With reference to Indian satellite launch vehicles, consider the following statements. First statement: PSLV launches satellites useful for Earth resource monitoring, whereas GSLV are designed mainly to launch communication satellites. Is that first statement is correct? Okay, next one is satellites launched by PSLV appear to be remains permanently fixed. Okay, and leave this second statement. Come to the third statement. GSLV Mk3 is a 4-stage launch vehicle with the first and third stage using solid rocket motors, and the second and fourth stage using liquid rocket engines. No. So answer is what? So second statement is also wrong. Answer is only one. Only one. Got it? So here, so this you know that. And remaining thing is regarding to the satellites. I will give information regarding to the satellites. Okay. So that is what regarding the question on rocket systems, how it can be asked. Okay. And next one is after these reusable launch vehicles. Next one is Gaganyaan mission. Gaganyaan. Have you heard about this Gaganyaan? So what is the objective of this Gaganyaan? What is the objective of this Gaganyaan mission? So Gaganyaan mission is this. What is the objective of this Gaganyaan project is? India's target is to send 3 astronauts for 3 days. Okay, 3 astronauts for 3 days into the 400 kilometers orbit, that is lower Earth orbit, and bringing them back safely to the Earth. Are you getting it? That is what the objective of this Gaganyaan project. And to fulfill this objective, what we are doing is we have manufactured this. We started manufacturing this human rated launch vehicles Mark 3. As a part of human rated launch vehicles Mark 3, we developed this rocket system, human rated launch vehicle systems. Okay, now see this, it has solid propellant boosters. Okay, now this is human rated launch vehicle that we call it as an HS solid propulsion. And next one is in between it is liquid propulsion. And next one it is cryogenic stage. And it is orbital module. Next one is crew escape systems. This is what the design of what we call it as an human rated launch vehicles, which as a part of a Gaganyaan mission we want to develop. Okay, in this human rated launch vehicles, friends. So if you see this orbital module, in this orbital module again 2 stages are there. One is what means crew module, service module. Crew module is so this. If you see this crew module consists of habitable space like Earth. Astronauts to sustain. So they need oxygen, they need temperature, they need pressure. Okay, like Earth-like environment has to be maintained. So where we will maintain Earth-like environment means crew module. And service module is a backup of crew module. Service module is the backup of crew module. Got it, students? That is what as a part of human rated launch vehicles what we are developing is. Okay, now, so I will draw for this. I will draw this human rated launch vehicles. Take it in Gaganyaan mission. Take it in Gaganyaan mission, students. So there are 2 types of missions like this: Gaganyaan, Samudrayaan. Samudrayaan means sending of humans into the deeper layers of the oceans. Gaganyaan means sending of humans into the outer space. Both are not accessible to the humans. Okay, now, they are not easily accessible to the humans. Hence, we are trying to send humans for further exploration purpose. Okay, now, so take it in Gaganyaan. The main objective of Gaganyaan is sending of 3 crew members. Sending of 3 crew members for 3 days. For 3 days. And bring 3 days into the lower Earth orbit. 3 days into the lower Earth orbit of 400 kilometers. Into the lower Earth orbit of 400 kilometers. Lower Earth orbit of 400 kilometers and bringing them back. And bringing them back safely to Earth. Bringing them back safely to Earth. Copy this. So somehow I managed it, the shape. Okay, right like that only. HS solid propellant boosters, liquid stage, cryogenic stage, orbital module. Next one is crew escape systems. What students? Completed? Next one is human rated launch vehicle. Take it in. Human rated launch vehicles. Human rated launch vehicle Mark 3. Human rated launch vehicle Mark 3. It consists of solid, liquid, and cryogenic stages. Solid, liquid, and cryogenic stages. Liquid and cryogenic stages. With the help of this rocket, orbital module will be launched into the 400 kilometer lower Earth orbit. 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 Okay, next one is orbital module consists of two types of module. One is crew module. Next one is service module. Crew module, service module. Crew module is a habitable space. Crew module is a habitable space with Earth-like environment. Service module is a backup. Service module is a backend system to the crew module. Backend system to the crew module. Okay, that is what crew module as well as service module, which is a part of orbital module. Okay, this is what the features of human rated launch vehicles. So these are the futuristic vehicles of what means India. Okay, now so there is a question in mains examination, students. Okay, this is I'm talking about 4 years back. So what does that means? India, many countries like Russia and USA has already sent astronauts into the space, but India is one of the competitor among them. But still, India is unable to send astronauts into the space. Critically analyze. Okay, now this is the question. So why India is unable to send astronauts into the space? We should know that. So it is too early to write. After discussing all the things, satellites and all, International Space Station, we'll write this question. Okay, now, so but I'm making you aware of that. This is the question what was given in the examination. What is an International Space Station? What are the benefits of International Space Station? Why many countries in the world are trying to launch their International Space Stations? What is the benefit of International Space Station? This is one of the questions. Got it? So that such kind of questions are given in the examination, students. Okay, next one is historical launch vehicles. What are these historical launch vehicles means? Historical launch vehicles. That is, one is SLV-3, Satellite Launch Vehicle 3, India's first experimental satellite launch vehicle, which has all solid 4 stages. Okay, now, and it can carry a payload of 40 kg payload into the lower Earth orbit. Okay, now, this is what regarding to the satellite launch vehicle. How many stages are there in this satellite launch vehicles? 4 stages are there. All these 4 stages are of solid stage. And how much weight it can carry means 40 kg weight. Okay, now, so this is enough for historical launch vehicles. Take it in SLV-3, Satellite Launch Vehicle 3. SLV-3, that is Satellite Launch Vehicle 3. It is India's first experimental satellite launch vehicle. India's first experimental satellite launch vehicle, consisting of 4 stages. With a solid propellant. And it can carry a payload of 40 kg into the lower Earth orbits. 40 kg into lower Earth orbit. Into the lower Earth orbits. ASLV, augmented satellite launch vehicle. So how many stages it has? 5 stages, and all are solid. How much payload carry capacity? 150 kg into which orbit? 400 kilometers circular orbits. Okay, make a note of that. That's enough. Augmented satellite launch vehicles. It is a second generation of It is a second generation launch vehicle of India. Second generation launch vehicle of India, which is having 5 stages, and all are of solid propellant. All are of solid propellant. It has a capability of launching 150 kg class satellites. It has a capability of launching 150 kg class of satellites, 150 kg class of satellites into 400 kilometers orbit, into 400 kilometers circular orbits, into 400 kilometers circular orbits. Do I need to repeat? It has a capability of launching 150 kg of satellites into 400 kilometers circular orbits. Are you getting it, students? Okay, now that is SLV, satellite launch vehicle. How much weight it carry? 40 kg. Forty kg, ASLV 150 kg, PSLV 1700 kg, GSLV 2000 kg, GSLV MK3 4000 kg. Okay, now, so as the version of the satellite increases, payload carrying capacity of the satellite, so payload carrying capacity of the rocket increases. That shows the evolutionary nature of Indian rocket systems. How Indian rocket system is evolutionary in nature means in carrying of its payloads. In that sense, it is evolutionary in nature. Got it, students? Is it clear? So that is what regarding to the different types of rocket systems of India. In future, what India is trying to develop is India is trying to develop unified rocket systems. Unified rocket system means we don't need to have this many varieties of rocket systems. For launching of any satellite, we want a single type of rocket systems where any type of satellites should be launched into the orbits, either it is communication or remote sensing, whatever it may be. We want a unified rocket systems. So for that purpose, India is looking for that. We call it as a unified rocket systems are the futuristic rockets of India. That is imaginary stage. That is in hypothetical stage only up to date. Okay, no? That is what regarding the types of rockets. And now we'll go through these rocket engines. What are the different rocket engines that we have? I'm gonna take heading rocket engines. Rocket engines. What are the different rocket engines we have? Vikas engine. Okay, na? We have Vikas engines. Next one is cryogenic engines. Next one is semi-cryogenic engine. And next one is air breathing engines. Air breathing or air propulsion engines we call it as. So that is Vikas engine, cryogenic engine, semi-cryogenic engine, air breathing or air propulsion engines. What are the different air breathing or air propulsion engines means? Ramjet engine, scramjet engine, dual mode, ramjet engine. Ramjet, scramjet, dual mode, ramjet. Dual mode ramjet engines. These are the different types of engines what we are using currently in the rocket systems. Okay, now first, when it comes to the Vikas engine, so first stage of rockets are what? SLV 3 rockets. India's first generation of rocket is SLV 3. Second generation is ASLV. In ASLV we use solid rockets. That means solid fuel rockets. Generally, rocket fuel exists in solid, liquid, gaseous. Okay, now, so directly we want to use gases. We will compress the gases. We will use it in the form of liquids. When we are using solids, so India has well experience with the solid fuels. Okay, now in SLV, ASLV, and PSLV also we have used solids. Still we are using solid fuels. Okay, now solid fuels are unavoidable. We should use it because they produce more thrust. Thrust means force. And always, whenever you see this, solid fuels are always used in the first stage. It is a compulsion for us. For what purpose it is a compulsion? For what purpose means once the solid fuel was initiated, it cannot be stopped in the middle. Until it is completely exhausted, it will burnt out. Hence, we need to use only in the first stage, and that too, the solid fuel produces more thrust. During the initial takeoff of rocket, solid fuels are efficiently useful for India. That is one thing. And what is the benefit of liquid fuel means? Liquid fuels means solid fuels are easy to maintain, students, but liquid fuels is too much costly. And that too, this liquid fuels, we can switch on the the rocket engine and we can switch off the rocket engine whenever we want. That facility is there with the liquid fuels. And gaseous fuels, why we are looking towards gaseous fuels means with less fuel we can produce more thrust, but the cost of the fuel becomes very cheap because of their abundancy. And next one is, by launching, when we move out of the atmosphere, there won't be any oxygen. And we want to, when we use directly oxygen as a fuel, that will be added benefit for us. Okay, now, hence, because of that, we are using these three different types of fuels. And how we plan different fuels in different stages means, on what basis we have planned it means, based on the payload carrying capacity of rockets. Different payload carrying capacity of rockets. Based on the payload carrying capacity of rockets, they will plan the fuels in each and every stage. Got it, students? That is what. But every fuel has its own benefits as well as drawbacks. Okay, next one is coming to this Vikas engine. Vikas engine is the liquid fuel engine of India. Nambi Narayan is considered as father of Indian liquid propulsion technology. He developed this Vikas engine, and for the first time in India, this Vikas engine was used in where means second stage of PSLV rocket. Okay, now what is this Vikas engine? Vikas means, see, what is the full form of this Vikas? Vikas means not that one. Vikas means Vikasa. Vikas means Vikram Ambalal Sarabhai. So this is the full expansion of Vikas. Okay, now this Vikas engine was developed based on the Viking engine of France. It is the most successful engine of France. Based on this Viking engine, we have developed our Vikas engine. That is Vikram Ambalal Sarabhai, and it was developed by whom means Nambi Narayan. He is considered as father of Indian liquid propulsion technology. Got it, students? And we started using with the help of PSLV rocket in second stage, and later on we started using in GSLV Mk2. Later on we started using in GSLV Mk3. Okay, students, that is what regarding this Vikas engine, and it is India's indigenously developed liquid propulsion technology. Okay, now make a note like this: Vikas engine. Vikas engine is an India's indigenously developed liquid propulsion engine. India's indigenously developed liquid propulsion engine. Liquid propulsion engine. Okay, it was developed based on Viking engine of France. Viking engine of France. Okay, next one is for Nambi Narayan. Nambi Narayan is considered as father of Indian liquid propulsion technology. Father of Indian liquid propulsion technology. Father of Indian liquid propulsion technology. You know, and it was started using first with PSLV rocket systems. PSLV rocket systems. You know, that is what regarding this PSLV and Vikas engine. What is this Vikas engine means? How it was developed means. Coming to this cryogenic and semi-cryogenic engines. See, cryogenic engine was used only in the third stage of GSLV rockets, not in any other stages, only in the upper stage. So I will give background history regarding this cryogenic engine. Initially, during the GSLV Mk2 or LVM2 rockets, we used to bring this. We have a memorandum of understanding with Russia. Russian GK company used to supply this cryogenic engines to India as a part of this memorandum of understanding. And as a part of this MOU, not only the supplying of engine technology, they have given Russia has given promise that it will help India in developing cryogenic technology indigenously. So that is what the MOU between India and Russia. But later they have supplied the cryogenic engine to India, no doubt in that. But most of the engines has ended in a failure manner. Out of 15 launches in GSLV Mk2, 4 failures are there. 4 failures are because of cryogenic engine. Okay, students. Next one is why Russia has not supported India in developing this cryogenic engine means. So US and France doesn't want India to develop cryogenic engine. Once India has a cryogenic engine, it will become a competitor for US and France in launching heavier satellites into the orbits. Okay, now that is the reason behind this what we call not to transfer cryogenic technology to India, as well as not to assist in developing of cryogenic technology. They pressurized Russia not to supply these technologies to India. But India never stopped its efforts. Even though Russia has not supported in developing cryogenic engine, we have developed our cryogenic engine indigenously. India has shown the soft power to the world, so in developing of technology. Okay, now India has given a message to the world that even though no country supports India in developing of technology related to the space, India has never stopped. Okay, now if you supply technology to India, that is very good. If you are not supplying technology to India, it is very, very good. Okay, now why? Because India will start developing on its own. If India starts developing on its own, it is a threat to you only. Okay, now why? Because such a huge population and that to surrounding countries of India. And next one is India is going to become one of the biggest economic power in future. Okay, now this all counts there. If India started developing on its own as a part of Atmanirbhar Bharat, okay, now self-reliance. If it becomes self-reliance, it is a threat to those countries or not? Yes. So that is what. And we have shown to the world that so India can develop any technology. And what is this conspiracy of Nambi Narayan? Nambi Narayan, after developing this cryogenic, what we call Vikas engine, he started focusing on this cryogenic engine technology. Okay, now, so Nambi Narayan is one of the most famous scientists at the time. And if we control Nambi Narayan developing this technology, so India can stop developing technology for a certain point of time. And because of that conspiracy, so India is unable to develop cryogenic engine for 20 years. After 20 years only we have developed it. Otherwise we might have developed this cryogenic engine 20 years back itself. Okay, now, because of that conspiracy, it became late in developing this cryogenic engine technology. Okay, now, that is one thing. And next one is regarding this cryogenic engine. We use this cryogenic engine only in the upper stages of the rocket, but not in any other stages. Why? Because in the upper stage, So cryogenic engine consists of a fuel known as liquid oxygen and hydrogen. Always hydrogen combustion takes place in presence of oxygen and it results in production of water. Is it environmentally friendly or not? Next one is, once the rocket crosses the atmosphere, oxygen availability doesn't exist. If oxygen availability is not there, okay, now we have to carry extra oxygen tank for the combustion of this fuel. Okay, now we don't want to carry extra oxygen tank. In PSLV we used to do like that. By carrying extra oxygen tank in the fourth stage of PSLV rocket, the payload carrying capacity of the rocket has been reduced. Okay, now, and next one is coming to the GSLV. When we started using liquid oxygen, liquid hydrogen directly as a fuel, we have removed the carrying of oxygen tank, and payload carrying capacity of the GSLV rocket has been enhanced according to the weight of the oxygen tank. Okay, students, that is one thing. And cryogenic engine, when we are using liquid hydrogen and oxygen, it perfectly maintains the velocity in launching the satellites into the orbit, that is 11.2 kilometers per second. Got it, students? So this is the benefit of what we call it as a cryogenic engine. Once after India developing the cryogenic engine, once after success of this cryogenic engine, India was declared as a self-reliance country in the world. In what sense it is a self-reliance means? Before cryogenic engine, in launching of 4,000 kg of satellites into orbit, India doesn't have a capability. So we have to take the services of France and USA. But these France and USA are not providing the services whenever India want. Launch on demand services are not there. Okay, now, there will be, because of that, there is a too much delay in launching of satellites into the orbit. And that too, we have to listen to them whenever they want to launch, they have to launch. We have to launch, we have to listen to their words. And after developing cryogenic engine, we got capability of launching heavier satellites into the orbit, and India immediately declared as a self-reliance country in the world. And now we started providing services to other countries. In the space economics, India is trying to play a key role. Now our percentage is just 3% only. In future, we want to enhance our percentage in launching of satellites into the orbit. We want to provide launch on demand services to many countries in the world. That is what our target is. Okay, students. For that purpose, we developed this cryogenic engine. We have succeeded it. And what US and France is saying openly, they are not saying that India will become a competitor for US and France. They are saying that India in 1974 already tested one nuclear weapon, and in 1998 they have tested another nuclear weapon. They already have nuclear technology. When you supply cryogenic engine, with this cryogenic engine, they will develop a nuclear warhead carrying missiles. That is a threat to the world. Okay, now they are saying like that openly. But behind their ideas, what is the real idea means? Reality means India will become a competitor for France and USA in launching the satellites into the orbits. Hence, they stopped Russia in transfer of technology, in assisting the cryogenic engine development technology, as well as conspiracy behind this Nambina Rain is also because of those countries. It was not proved, but they are saying that because of that. Okay, because of stopping one person, it has delayed. Development of cryogenic engine technology in India has been delayed up to 20 years. Got it, students? This is what the historical concept behind this cryogenic engine. Why cryogenic engine is used only in the upper stage means because when rocket crosses the atmospheric layers, oxygen availability won't be there. Hence, in cryogenic engine, we are directly using it as a fuel of liquid oxygen hydrogen mixture. Got it, students? That is what regarding this. And why we are looking for semi-cryogenic engine? Semi-cryogenic engine is a superior version of cryogenic engine. Okay, now in cryogenic engine, we are using liquid hydrogen and oxygen as a fuel. We are using liquid hydrogen plus oxygen as a fuel. But in semi-cryogenic engine, we are using highly refined kerosene oil. Highly refined kerosene oil is used. Okay, now next one is in cryogenic engine, low temperatures. Cryogenic temperatures are required. Cryogenic means minus 80 to minus 200, 300 degrees. We call it as a cryogenic. Very low temperatures need to be maintained. But semi-cryogenic engine can be operated at room temperatures. Okay, now that is another benefit. Both cryogenic and semi-cryogenic engine can produce the same thrust, and production of hydrogen is too costly. Transportation of hydrogen is too costly. But production of kerosene oil is cheaper. Got it, students? So hence, India is looking towards this development of semi-cryogenic engine. That is what the concepts regarding to cryogenic, semi-cryogenic. What is the historical background of cryogenic engine? Shall we write about this? Okay, now are you ready? So ready, right? PSLV. What is that? So far they have not used cryogenic. So far, cryogenic engine. So far it was not used in PSLV rockets, but they can use it. Okay, make a note. Cryogenic engine. Cryogenic means minus degree temperatures. Minus degree temperatures. Minus degree temperatures. This cryogenic engine is used. This cryogenic engine is used only in the upper stages of GSLV rockets. Only in the upper stages of GSLV rockets. Okay, now next one is in PSLV fourth stage, extra oxygen tank will be placed. Extra oxygen tank will be placed for combustion of fuel. In outer space. For combustion of fuel in outer space. But in cryogenic engine, but in GSLV rockets, no need of carrying extra oxygen tank. No need of carrying extra oxygen tank, because oxygen itself is used as a fuel propellant mixture. You know, that means in cryogenic engine, fuel used is liquid oxygen. Write in the bracket after liquid oxygen minus 183 degrees. Liquid oxygen after liquid oxygen, write in brackets minus 183 degrees. Next one is liquid hydrogen. Minus 253 degrees. Minus 253 degrees. So these are what means liquid in nature. Basically, liquid oxygen, liquid hydrogen is what means gaseous. What basically the nature of liquid oxygen and hydrogen, friends? Hydrogen and oxygen generally exist in gaseous form, but we will compress and we will convert it into a liquid form. Why we will compress and convert it into a liquid form? To accommodate more fuel within less space. Got it? That is what. Next one is. Got clarity on this? So what is the temperature that we used? And it is a mixture of liquid oxygen and hydrogen. Here you may get doubt that what is the difference between fuel and propellant. Fuel means it has only one single chemical composition. Propellant means it is a combination of fuel plus oxidizer. So listen carefully, students, people who came from arts background. Any fuel, if you have to combust, any fuel, that is kerosene, petrol, diesel, coal, any fuel, if you have to combust, you need oxygen. Without oxygen, we cannot produce fire. We cannot produce energy. Oxygen is compulsory. Hence, when we cross the atmosphere, does oxygen will be there? No, no. Hence, we need to carry extra oxygen tanks. The same thing we have done it in PSLV rocket. If you are carrying extra oxygen tank, what happens? The payload carrying capacity of rocket will be reduced. We want to enhance the payload carrying capacity of the rocket. Hence, we have replaced that with cryogenic engine. And GSLV payload carrying capacity has been increased up to 2000 kg from 1700 in PSLV. Have we done it or not? That is what the thing is. Got clarity, students? That is what. Next one is unknown. Benefit of using cryogenic engine in third stage of the rocket. Benefits of using cryogenic engine. Benefits of using cryogenic engine. I will give you. Benefits of using cryogenic engine in third stage or upper stage of GSLV rocket is. In third stage or upper stage of GSLV rocket is. First one is oxygen availability in outer space. Oxygen availability in outer space. Oxygen availability in outer space. Cryogenic engine itself here use oxygen. Are you there in the class? Listening to the class. Okay, oxygen availability in upper stage. Next one is outer space. That means next one is unknown is. It perfectly maintains the speed. It perfectly maintains the speed of 11.2 kilometers per second. Maintain the speed of 11.2 kilometers per second in launching the satellites into orbit. In launching satellites into orbits. In launching satellites into orbits. Okay, no? That is the second point. And third one is use of liquid oxygen and hydrogen. Use of liquid oxygen and hydrogen as a propellant. Carbon footprints of rocket can be reduced. Carbon footprints of rocket can be reduced. Okay, now next one is India's payload carrying. Indian rocket payload carrying capacity has been enhanced. 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 Okay, these are the benefits. Next one is. Got clarity on this ones? What is the benefit of cryogenic engine? What are the fuel propellants that are used in the cryogenic engine? Next one is historical aspect. Take it in historical aspect. Historical aspect. Today you'll get nice sleep. Okay, now. So right on this. India has signed a memorandum of understanding. India has signed MOU. India has signed MOU with Russia. In transfer of technology. In transfer of technology. As well as developing cryogenic engine. As well as developing cryogenic engine. As well as in developing cryogenic engine. But Russia didn't support. But Russia didn't support. Even though Russian GK company has supplied cryogenic engine to India, it has ended in failure manner. It has ended in a failure manner. Later India has developed cryogenic engine. Indigenously. Cryogenic engine indigenously. And it was declared as self-reliance country. It was declared as self-reliance country in launching heavier satellites into orbit. Heavier satellites into orbit. Right in the bracket after that. Earlier India depends on France and USA. You know. Shall we need a break? Okay, na? Just we'll write complete these limitations and I will give a break. Okay, na? Even though cryogenic engine seems to be successful, even though cryogenic engine seems to be successful, there are certain limitations. certain limitations. One is, first one, maintenance and operation cost is very high. Maintenance and operation cost is very high. Second one is, production and transportation of hydrogen is too costly. Production and transportation of hydrogen. Production and transportation of hydrogen is too costly. Next one is, very cold temperature has to be maintained. Very cold temperatures has to be maintained. That is right in the bracket, cryogenic temperatures. Cryogenic temperatures has to be maintained. Okay, that is, these are the limitations. To overcome these limitations, we started focusing on developing semi-cryogenic engine technology. Semi-cryogenic engine technology. Okay, no? So right, cryogenic versus semi-cryogenic. Take heading, cryogenic versus semi-cryogenic. Cryogenic versus semi-cryogenic. Take a break. After the break, we'll write this. Get some energy, we'll write. So I will tell you. I will give you the information regarding to propellant, fuel, liquid, solid, propellant, everything I will give you. Today, little bit what writing part will be there. But if you write, if you maintain the notes, it will give clarity on everything. Okay, now is it okay? Okay, take a break. Next one is cryogenic engine versus semi-cryogenic engine. So what is the basic difference between cryogenic and semi-cryogenic first? So what is the fuel used in cryogenic engine? Liquid hydrogen and liquid oxygen. First write that. Fuel used is liquid oxygen and liquid hydrogen. Among this liquid oxygen and liquid hydrogen, which one is the original fuel? Hydrogen is the original fuel. Oxygen will act as oxidizer. Got clarity? Okay, next one is in semi-cryogenic engine. What is the fuel used in semi-cryogenic engine? Highly refined kerosene oil. Highly refined kerosene oil. Okay, next one is cryogenic engine will be maintained at very low temperatures. Cryogenic engine is maintained at very low temperatures. Very low temperatures. But semi-cryogenic engine is maintained at normal temperatures. Maintained at normal temperatures. Next one is cryogenic engine. Next, another point is maintenance and operation cost is high. Maintenance and operation cost is high. Semi-cryogenic. In semi-cryogenic, less maintenance and operation cost. Less maintenance and operation cost. Less maintenance and operation cost. Okay, next one is, what is the next point? Difficulty. Hydrogen production and transportation is difficult. Hydrogen production and transportation is difficult. Hydrogen production and transportation is difficult. Next one is kerosene. Easy. Kerosene oil can be easily produced. Okay, no? That is what the basic difference between cryogenic and semi-cryogenic. Okay, no? Right under that, below that, semi-cryogenic engine. No, common point. Difference is completed. Below that, write one common point. Okay, no? Semi-cryogenic engine is superior to cryogenic engine. Superior to cryogenic engine. Okay, no? That is what the cryogenic engine as well as semi-cryogenic engine differences. So all about this cryogenic engine students. Got clarity on this? Okay, no? Next one is air breathing engines. So before going to this, wait. Okay, no? Before going to know about this air breathing engines, first we need to know about what are the drawbacks of Indian rocket systems. And to overcome these drawbacks, we have started focusing on air breathing engines, air propulsion engines. So what are the drawbacks? Why it has led to why we are focusing on this what we call air propulsion engines or air breathing engines? I will explain it. So in India, whatever the rocket systems we have, the efficiency of these rocket systems is very less. Efficiency of the rocket systems is very less. Efficiency means what? Means the weight that is able to carry. Our rocket systems is able to carry only 2 to 4% of the total lift off mass. Okay, in the total weight of rocket, payload carrying capacity of rocket is just 2 to 4%. Hence, rocket launch means launching of satellites into the orbits becomes too costly. And that too, we are using it for only one time. We are not using it again and again. Okay, and next another one is, but within this weight of the rocket, total weight of the rocket, 70% of the weight belongs to the propellant. So propellant means fuel plus oxidizer combination. Okay, now, out of the 70% of the weight, means 70% is of the propellant. So oxidizer weight is very high students in the fuel. Oxidizer weight is very high. We want to reduce this oxidizer weight. So carrying capacity, that means payload carrying capacity of the rocket is very less, and followed by 70% weight of oxidizer in fuel propellant. These are the two major drawbacks. Okay, now, we want to overcome this. Hence, we started focusing on air breathing engines. In 2016, ISRO has launched ISRO's air breathing propulsion project. ISRO's air breathing propulsion project in 2016. What is under this ISRO's air breathing propulsion project? We started focusing on ramjet, scramjet, dual mode ramjet. Okay, now, so what is the specialty of these engines is they use hydrogen as a fuel, no doubt in that. Ramjet engine, dual mode ramjet. When the rocket is moving like this, or when the engine is moving like this, it takes oxygen from the atmosphere like this. That means it breathes oxygen from the atmosphere. Are you getting it, students? Hence, there is no need of using, means carrying oxidizer tank. Means 70% of the weight has been reduced or not? As the weight of the rocket has been reduced, efficiency of the rocket can be increased. That to hydrogen. Hydrogen has high calorific value when compared with other fuels. Hence, Payload carrying capacity of the rocket can be further enhanced. As a part of this, first we have launched ramjet engine. Ramjet engine, so this most efficiently at supersonic speed around Mach 3 and can operate up to Mach 6. However, ramjet engine efficiency starts to drop when the vehicle reaches hypersonic speeds. Are you getting it, students? When the vehicle reaches hypersonic speeds, that means ramjet engine is efficient at supersonic speeds. Okay, next one is after this scramjet engine. Scramjet engine means, what is the full form of scramjet? Means supersonic combustion ramjet. This scramjet engine is improvised version of ramjet engine. It efficiently operates at hypersonic speeds and allows supersonic combustion. What is the meaning of that? Means in this engine, since hypersonic air is coming inside, okay, now, the fuel combustion, hydrogen fuel combustion takes place at supersonic speeds. In this, fuel combustion takes place at supersonic speed, but the rocket travels at hypersonic speeds. As a part of supersonic combustion, whatever the exhaust that is produced, this exhaust makes the rocket to travel at hypersonic speeds. Hypersonic means it is more than supersonic. Okay, now, hence we call this engine as supersonic combustion. Supersonic combustion ramjet engine means fuel combustion takes place at supersonic speed, vehicles travels at hypersonic speeds. Okay, the next one is if you see dual mode ramjet. It is a type of jet engine where ramjet transforms into scramjet at a speed of 4 to 8 range. This means this engine both act as ramjet as well as scramjet. Based on the speed, it will switch from ramjet to the scramjet. But here, if the fuel combustion is taking place at supersonic speed, vehicles travels at if the fuel combustion takes place at subsonic speed, vehicle travels at supersonic speed. If the fuel combustion takes place at supersonic speeds, vehicle travels at hypersonic speeds. Got it? In ramjet engine, fuel combustion takes place at subsonic speed and the rocket travels at supersonic speed. In scramjet engine, fuel combustion takes place at supersonic speeds and the rocket travels at hypersonic speeds. Dual mode rocket means what? Means it can switch from supersonic to, that means ramjet to scramjet at a Mach range of 4 to 8 Mach range. Why we have developed? Is it clear now? Air breathing engine means it takes oxygen from the atmosphere, and what is the fuel used here? Hydrogen is the fuel used. When hydrogen combustion takes place in presence of oxygen, what is the output? Water is the output. Is it environmental friendly or not? Yes. India recently developed a scramjet engine, tested the scramjet engine, succeeded in developing of scramjet engine. In future, India has a capability to develop hypersonic technologies. Okay, now, are you getting my points, friends? So that is what? Air breathing engines. Hypersonic, I will give basics. Basics, after this I will give you. So speed of the missiles or engines will be measured based on the speed of sound. Okay, now, any missile or rocket, when it is traveling equal to the speed of sound, we call it as sonic engines. Below the speed of sound, subsonic. 3 to 4 times the speed of sound, supersonic. 5 times the speed of sound, hypersonic. That is what. Okay, now, make a note like this. Even though India has well experienced, even though India has well experienced in developing and maintaining of rocket systems, it has following limitations too. It has the following limitations. It has the following limitations. One is, our launch vehicles are designed for one-time use. Our launch vehicles are designed for one-time use. And are expensive. And their efficiency is low. Because they can carry only 2 to 4% of their lift of mass to the orbit. 2 to 4% of the lift of mass to the orbit. 2 to 4% of lift of mass to the orbit. Thus, there is a worldwide efforts. To reduce launch cost. Okay, next one is second point. Nearly 70% of the propellant. 70% of the propellant carried by today's launch vehicles. Nearly 70% of the propellant carried by today's launch vehicles consists of oxidizer. Therefore, next generation launch vehicles must use a propulsion system. Which can utilize atmospheric oxygen. Hence, ISRO's air breathing propulsion project was launched. ISRO's air breathing propulsion project was launched in 2016. Under this project, the following engines have been developed Under this project, the following engines has been developed as well as in under development. 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 One is ramjet, scramjet. Next one is dual mode ramjet. Dual mode ramjet. Okay, no? Next one is ramjet engine first. Ramjet engine. So works efficiently at. So we are writing directly from ISRO's website source. Any book has to copy it from here only. Okay, no? Whatever the book you purchase. If you have extra money, you can donate to Vision. You know, ramjet works. Ramjet works most efficiently at supersonic speed. Ramjet works most efficiently at supersonic speed around Mach 3. Around Mach 3. Right in the bracket. 3 times the speed of sound. 3 times the speed of sound. And can operate up to what speed? Mach 6. And can be operated up to Mach 6. And can be operated up to Mach 6. However, ramjet engine efficiency drops. However, ramjet engine efficiency drops when the vehicle reaches hypersonic speed. When the vehicle reaches hypersonic speed. When the vehicle reaches hypersonic speed. Vehicle reaches hypersonic speeds. Next one is scramjet engine. Scramjet engine. It is an improvement over ramjet engine. It is an improvement over ramjet engine. It is an improvement over ramjet engine. As it efficiently operates at hypersonic speeds. As it efficiently operates at hypersonic speed. And allows supersonic combustion. And allows supersonic combustion. Thus it is known as supersonic combustion ramjet. Thus it is known as supersonic combustion ramjet. Supersonic combustion ramjet. Right in bracket. In shortcut it is known as scramjet. Scramjet. Next one is dual mode ramjet. Dual mode ramjet. Dual mode ramjet is a type of jet engine. Is a type of jet engine where a ramjet transforms into scramjet. Scramjet over a Mach of 4 to 8 range. Over a Mach of 4 to 8 range. Okay, which means it can efficiently operate both in subsonic and supersonic combustion mode. Where 4 to 8 range, which means it can efficiently operate both in subsonic and supersonic combustion modes. Supersonic combustion modes. Clear? Up to this, is it clear? All the types of rocket engine and their historical backgrounds and all. Okay, now conspiracy lies where means in developing cryogenic engine. Okay, now hence there starts the conspiracy, students. Okay, now, on Nambi Narayan, that is one thing. There is a very good question from online students. Listen carefully. Sheikh Muhammad Suraj. Sir, outer atmosphere doesn't contain oxygen. Then how can a ramjet engine travels? See, listen carefully, students. Ramjet, scramjet, dual mode ramjet is operated only within atmosphere. They are not used outside the atmosphere. Within atmosphere, we will use this. Outside the atmosphere, cryogenic engine. Cryogenic engine can be used outside the atmosphere, within the atmosphere. But ramjet, scramjet, and dual mode ramjet can be used only within the atmosphere. In future, when we are developing reusable launch vehicle, rocket starts with Vikas engines. When it is supersonic mode, it will use ramjet, hypersonic mode, scramjet. If it is in outer atmosphere, cryogenic engine, and reverse. Again, from space, cryogenic engine, scramjet, ramjet, landing. Got it? Landing means it may fall into the water. It may land with the help of aeroplane. Okay, there are different types of landing out there. Other than asking the astronaut to jump from the space, remaining 2 landings are the soft landings are there, we call it as. Got it? That is what we want to develop a reusable launch vehicle technologies or human rated launch vehicle technologies. Are you getting my point? Okay, now. So remember, scramjet, ramjet, dual mode ramjet can be used only within the atmosphere. Ramjet, supersonic speed. When the supersonic speed is not maintained, efficiency of ramjet drops. Okay, now. Scramjet, only hypersonic speed. When hypersonic speed is not maintained, scramjet engine efficiency drops. So the limitation of these engines is that only. The proper speed, that particular proper speed has to be maintained. If the speed has not maintained, the engine efficiency drops. Got it, students? That is what all these rocket engines. Clear? Is it clear now? Okay, now, next, take it in. Do you know? Fuel means it is a single chemical composition. It is a single chemical composition. Propellant means it is a combination of fuel plus oxidizer. Combination of fuel plus oxidizer. Any fuel combustion Any fuel combustion takes place in presence of oxidizer. Takes place in presence of oxidizer. Any fuel combustion takes place in presence of oxidizer. Examples of oxidizer are oxygen, NO2, nitrogen dioxide, N2O4, dinitrogen tetroxide. Okay, no? That is what, etc. Okay, no? These are the generally used oxidizer along with oxygen. Got clarity? Is it clear now? What is a fuel? What is an oxidizer? What is a propellant? That is what do you know means. Okay, the next one is take it important points. Any fuel exists in three states. That is solids, liquids, and gases. Liquids and gases. Okay, no? In case of rockets, solids are always used in first stage. Solids are always used in first stage because once it is combusted, it doesn't stop until it exhausts. It doesn't stop until it exhausts. And maintenance and operation cost is also less. Along with more thrust production than other fuels. So generally, if you see in the SLV, ASLV, PSLV students, once after the solid fuel has been combusted totally, the part will be separated from the rocket. Why it will be separated means, if it is there, it will put weight on the rocket. If it is removed, the weight of the rocket will be reduced. And whatever the rest of the fuel that is there, it will be sufficiently used for launching the satellites into the orbits. If the weight is there, it has to combust more fuel, and fuel sufficiency will be reduced. Are you getting my point? Hence, rocket parts will be separated. Got clarity? So, done? Okay, do I need to repeat once again? No? Okay, no. Next one is liquid fuels. Operation and maintenance cost is high. But we can switch on and switch off engine. Conveniently. Switch off and switch on engine conveniently at any time. Okay, no? That is. Next one is gaseous fuels. Are compressed and will be maintained in a liquid form. Okay, no? Upcoming version of fuels are hybrid fuels. That is solid plus liquid fuels. Okay, no? Use of fuels in different stages of rockets depends on the payload carrying capacity of the rocket. As well as time that was allotted to operate particular stage. Is it clear, students? So say for example, just take a break, small break. Okay, now listen. Okay, now. So in GSLV Mk2, that is LVM2, we have used CE 7.5 kilonewton engine. When it comes to GSLV Mk3, we have used CE 20 kilonewton engine. That means engine capacity has been increased. When the engine capacity has been increased from GSLV Mk2 to GSLV Mk3, the payload carrying capacity has been increased or not? Yes. So why it has been increased? Because fuel accommodation has been increased. And next one is based on the fuel's capacity, payload carrying capacity also has been enhanced. That is one thing. Next one is when I was referring with the CE20 engine, that stage was coded as C25. I have shown you. Okay, now what is the meaning of that? Means that particular stage will be operated for 25 seconds. According to that, they have designed the fuel. In every rocket, first stage is always solid fuel. Why solid fuel? Because it produces more thrust. That is one thing. Once it is combusted, we can't stop it until it finish. Hence, we use solid fuels in the first stage itself. Are you getting my point, friends? Okay, that is what they think regarding the fuels in the rockets. Any doubts up to this? Rocket engines, rocket fuels, any doubt? So initially you asked why liquids, why solid, why this thing. Now got clarity on this? If you wait patiently, and you can get the clarity on each and every topic like this. Okay, next topic is orbits. In orbits, I will give clarity on all this. What are the different types of orbits and all? Got clarity, students? This is what rocket engines. This is what the fuels of the rocket. Next, we'll go for the other one. What is that means? Now we will take this after the completion of rockets and rocket engines. Next one is satellites. We need to go through this. Before that, I will take the topic of orbits and related concepts. What are the different types of orbits as well as concepts related to orbits? Okay, now done, students. Any doubts here? No. Next, take it in orbits. So what is an orbit, students? What actually is orbit? So whatever the doubts you have, I will clarify all the doubts. At the same time, I will give notes to the doubts if it is valid. Okay, students, you have to write it. You know? And what is an orbit? How can you define an orbit? What is that? Path. Orbit is a path. Is it really existing? No, it is imaginary in nature. Okay, now, orbits may be of circular and elliptical in nature. Okay, now, it may be of circular or elliptical in nature. It may be of lower Earth, medium Earth, higher Earth orbits. Okay, now, like this, different shapes of orbits are there, different things of orbits are there. So this, why orbit is necessary? What are the basic concepts regarding to the orbits? Say, for example, if a satellite or any object, not only the satellite, any object, it is revolving in a circular path. Okay, now, especially if it is a natural satellite or if it is an artificial satellite, it has to maintain its orbital velocity. Why it has to maintain its orbital velocity? What is orbital velocity? Orbital velocity means speed. Okay, now, so when Earth is rotating around the sun, does it maintain its speed or not? Yes. Why it maintains the speed? Why it has to maintain the speed? Because to overcome the gravitational pull of sun. And any artificial satellite, when it is revolving around the Earth, it has to maintain certain speed. Okay, now that speed which is related to the orbit, we call it as an orbital velocity. Okay, now if orbital velocity is not maintained, then what happens? Okay, now see, there are any object when it is revolving in circular or elliptical path, it experiences two types of forces: centripetal and centrifugal force. Centripetal is an inward force, centrifugal is an outward force. Centripetal is equal to the gravitational force. Centrifugal force is a pseudo force which doesn't exist in nature. It was created by the scientists for explanatory purpose. But centripetal is a real force which is equal to the gravitational force. If any object, when it is revolving in a circular or elliptical path, when it is maintaining its orbital velocity, then the resultant of centripetal and centrifugal force becomes zero. Then the particular object remains stable in that orbit. Got clarity, students? That is, if orbital velocity is not maintained, then it will be pulled towards the Earth. If orbital velocity is more than required, then it will flew away from the orbit. So hence orbital velocity should be maintained in a proper manner. Orbital velocity of Earth is approximately 7 kilometers per second. That speed has to be maintained by all the artificial satellites. Got it, students? And next one is, this is the concept related to the orbit. And what are the different types of orbits we have? Orbits are categorized into following types. One is based on shape. Based on shape. Next one is based on altitude. Next one is based on synchronous. Based on synchronous. Based on shape, orbits are categorized into following types: circular or elliptical orbits. Elliptical orbits like this. Next, based on altitude, lower Earth orbits, medium Earth orbits, higher Earth orbits. Based on synchronous, geosynchronous, and next one is sun synchronous. We call it as a sun synchronous. So this is what the categorization of orbits. Orbit is an imaginary line, imaginary path. Okay, now shape of orbits may be circular or elliptical. It depends upon the needs of the satellites. Okay, now shape of orbit, we humans design the shape of the orbit. Okay, according to our needs. It might be circular, it might be elliptical in nature. Okay, now done. Now copy this. So lower Earth orbits means copy like this, students. This is from ISRO's website reports. Lower Earth orbits means up to 2000 kilometers. Up to 2000 kilometers. Medium Earth orbit 2000 to 35,000 kilometers. Higher Earth orbits means 35 and above. 35 and above. Lower Earth means up to 2000 kilometers. Medium Earth means 2000 to 35,000 kilometers. Higher Earth means 35,000 and above. Right like this, 35,000 and above. You can write there itself in the flowchart. Okay, now don't draw the table. Just write lower Earth, medium Earth, higher Earth orbit, ranges. That's enough. Okay, now just I want to show you the ranges, hence I should display this table. Okay, now don't write the table total. Lower Earth orbits up to 2000 kilometers, medium Earth orbits 2000 to 35,000 kilometers, and higher Earth orbit means 35,000 and above. That's all. Done. Anyhow, I will send you this PPT. Okay, now, next one is right under that. Orbit is an imaginary path. Orbit is an imaginary path. Every natural and artificial satellites. Every natural and artificial satellite. Every natural and artificial satellite will have its own path. Will have its own path. Any orbit, any object revolving in a circular or elliptical path. Circular or elliptical path. It has to maintain its orbital velocity. It has to maintain its orbital velocity. Okay, right in the bracket. Orbital velocity of Earth is approximately 7 kilometers per second. Approximately 7 kilometers per second. You know, approximately 7 kilometers per second. If orbital velocity is maintained, then the resultant of centripetal as well as centrifugal force, resultant of centripetal and centrifugal forces becomes 0. Centripetal and centrifugal forces becomes 0. Okay, now copy this. Something more. Come on, more. Just.